Now let us draw the ray diagrams for image formation by a convex mirror. Here we are considering only two rays for drawing this diagram, and also we consider two positions of the object for studying the image formed by a convex mirror, because position of the object is not a matter in the case of a convex mirror, because it always form an erect, virtual and diminished image in all cases. So we need only two diagrams for understand the nature of the image formation by convex mirror. In our first case, we are placing our object is at infinity. So the same as concave mirror, you can choose some parallel rays. So this is the parallel ray and it is reflected back like this or diverged back like this, and this is another parallel ray. This is also diverged like this. But this extrapolation of this diverged ray seems to meet at this focus. These appear to meet at this focus. This is the incident ray, this is the reflected ray, and this is the incident ray, this is the reflected ray. So the extrapolation of this reflected rays meet at the focus behind the convex mirror. Actually this is a virtual meeting, not an actual meeting. So we can say that the image is formed at focus virtually. So this is a virtual image, point sized, highly diminished and also erect image. In our second case, we place the object is at finite distance from the mirror. We can't say it is beyond center of curvature or at center of curvature like that, because the center of curvature, focus and all are lies behind the mirror. So here it is, we can say it is a finite distance from the mirror. So we are choosing two rays. The first ray is parallel to the principal axis. It is reflected back like this, but the extrapolation of this ray meet at focus. You can see this one here. So it is appeared to diverge from the focus. And also the second ray is, we can choose when a ray is appear to passing through the center of curvature, is reflected back through the same path. So the virtual ray is meet at this point A dash. You can observe this here. So here is the position. So we can say that these two reflected rays virtually meet behind the mirror, and it is almost in between focus and pole. So we can say that it is virtual image, erect image and diminished image, because the size of the image is less than as compared to the object. In our first case, we place the object is at infinity, and the second position is when the object is at a finite distance from the mirror. The ray diagram for the formation of image by a convex mirror for these two positions of the object are shown in the given figure. Do you know what are the uses of convex mirrors in our daily life? Convex mirrors are commonly used as rear view mirrors in vehicles. These mirrors are fitted on the side of the vehicle, enabling the driver to see traffic behind him to facilitate safe driving. Convex mirrors are preferred because they always gives an erect though diminished image. Also, they have a wider field of view as they are curved outwards. Thus, convex mirrors enable the driver to view much larger area that would be possible with a plain mirror. These are the uses of convex mirror in our daily life. Now let us discuss sign conventions for reflection by spherical mirrors. While dealing with the reflection of light by spherical mirrors, we shall follow a set of sign conventions called the new Cartesian sign conventions. In these conventions, the pole of the mirror taken as the origin. This is the pole. We are considering this as origin. The principal axis of the mirror is taken as the x-axis of the coordinate system. This is considered as x-axis. This is actually our principal axis of mirror. So the conventions are as follows. The first point is the object is always placed to the left of the mirror. This is the mirror. Is it a convex or concave mirror? That is not a matter. The object is always placed to the left of the mirror. That means in front of the mirror. This implies that the light from the object falls on the mirror from the left hand side. So we can say that the direction of light is always from the left to right. This is the instant light. So we always place the object to the left of the mirror. And next point is all distances parallel to the principal axis are measured from the pole of the mirror. Suppose an object is placed here. So we can measure the distance of object from the mirror. We are taking this is the origin. Pole is the origin, and you can measure the object distance from the pole. So we are considering like this. Take a scale and measure this distance from the pole to the object. And also suppose an image is formed behind the mirror in the case of a convex mirror. You should start your measurement from this pole. Place your scale here and measure this distance. Actually, this is our image distance. Our third point is all the distances measured to the right of the origin, that means along the x-axis, are taken as positive, while those measured to the left of the origin, that means the origin is at pole, are taken as negative. For example, suppose this is our object AB. So it is placed here. So we can take the distance from the pole. So we always measure this distance from the left side of this pole. From the left side. So we can take it as a negative value. Suppose the object is placed 5 centimeter from the mirror. We can take this value as negative because it always measuring from the pole and also left side of this mirror. So it is considered as negative. And suppose an image is formed here. So we are taking this distance from pole to right side of this image. Right side of this image. So we are considering this value is positive because this measurement is taken from the pole to right side of the mirror. So we can say that it is plus 5. Our fourth point is distances measured perpendicular to and above the principal axis are taken as positive. Suppose this object is placed perpendicular to this x-axis. So we can take this value above the principal axis. That means the object is placed above this principal axis and also it is perpendicular. So we are taking this value as positive. The distance of this object is taken as positive. But when an object is perpendicular to the principal axis and also it is placed below this principal axis, we are considering the value as negative. That means this is in the case of a concave mirror. Where is the real and inverted image is formed? There is a negative sign is occurred because it is always formed below this principal axis and also it is perpendicular to this x-axis. So we can say that A dash B dash is considered as a negative value and AB is perpendicular to this principal axis and also it is above the principal axis. So we can say that this AB is measured as in positive. The sign conventions are applied to obtain the mirror formula and solve related numerical problems. Students, today we discussed image formed by convex mirror, uses of convex mirror and sign convention for reflection by spherical mirrors. Hope you understood this module. Read your textbook and watch this video carefully. Thank you.